Okay. So once again, very good afternoon all. In the last lecture, we have started the problems based on the moment area method. Okay. So the one problem I think we have covered. So where the cantilever beam is subjected to the point load, and in that case, we have understood the procedure. That is, if they have asked to solve the problem by using the moment area method. So the first requirement is that we have to go for the BM calculation. After the BM calculation, we have to go for the or we have to draw the bending moment diagram, and whatever the area you will get under the BMD, that area we have to check, and their properties for the area calculation and the X bar calculation we have to use, and we have to go for the further calculation. And based on this one problem we have solved in the previous lecture, and then one more problem we have started in the last lecture, that is once again the cantilever beam is there and it is subjected to the point load. Okay, so up to the BM calculation in the last lecture we have studied, that is how to go for the BM calculation for this cantilever beam, how it is to be started from the right side of the section, and which sign conventions we have to use, and by using the sign conventions we have gone for the BM calculation and we have drawn the figure. Okay, but in the previous lecture also we have discussed, and once again I will explain, that is sometimes whatever the area you will get under the BMD, that area will be not a standard case, or it will not be standard cross-sectional area. Sometimes you will get the triangle, sometimes you will get the rectangle, sometimes you will get the parabolic curve also, but sometimes you will get some odd shapes where that properties are will not be available with us. If you look at this particular figure here, initially this figure number 1, this triangle as it is you will get, but this odd shape you will get from portion A to C, and for this particular odd shape the properties for the cross-sectional areas and their X bar calculations are not available. So for that purpose, what I have done, from this particular point I have drawn one dotted line, and due to this particular dotted line, this particular odd shape section, it is divided into the two sections, where one section I will get as a rectangle and another section I will get as a triangle. Now I am having the property of rectangle, I am having the property of triangle. Okay, so now my requirement is that I have to calculate the slope and deflection at point B. Okay, so what I will do, I will consider this point B as a reference point for the X bar calculation. So for the section number 1, I am calculate the X1 bar is equal to 2 by 3 into length of BC. Okay, but while calculating the X bar for the section number 2 and section number 3, so this X bar formula is applicable for the particular section only. Getting? So this X bar formula, every X bar formula is applicable for the particular section only. So here for the section 2, this is the rectangle, and for the rectangle the CG is concentrated at the center. Okay, so their X bar is L of AC divided by 2. Means up to the point C only I can take L of AC divided by 2. But what is my requirement? I have to calculate the deflection at point B. So what I will do, along with this particular X bar distance, this 3 meter distance also I have to add. Getting? So while calculating the deflection and slope at the free end point B, consider all the sections which are present to the left side of the point B. So that's why we have to check at which point we have to calculate the slope and deflection. जर मला B ला काढायचा असेल तर मी त्या B च्या लेफ्ट साइडचे सगळे क्रॉस सेक्शनल एरिया कॅल्क्युलेशन मध्ये काय करणार, कन्सिडर करणार. If someone is asking find out the slope and deflection at point C, so at that time I will not consider the effect of section number 1. Here I will consider the C point as my reference point. Now how many sections are present to the left side of the point C? जसं B ला काढताना 1, 2 and 3 तिन्ही पण प्रेझेंट आहे, त्यामुळे आपल्याला तिन्हीचा इफेक्ट घ्यावा लागणार. तसं C च्या लेफ्ट साइडला किती सेक्शन आहेत? 2. That is, this is a section 2 and this is section 3. So while calculating slope and deflection, I will consider the effect of 2 and 3 in slope calculation, and I will consider the effect of 2 and 3 in the deflection calculation. आता ह्या पॉइंट सी ला डिफ्लेक्शन काढताना एक्स बार इथून इथपर्यंत आपल्याला ऑलरेडी फॉर्म्युला माहित आहे, त्यामुळे पुढचं डिस्टन्स ऍड करायची काय गरज आहे का? जर बी ला काढायचा असेल तर सेक्शन 2 आणि सेक्शन 3 मध्ये आपल्याला 3 मीटर डिस्टन्स काय करावं लागणार आहे, ऍड करावं लागणार. जर मला सी ला डिफ्लेक्शन काढायचं असेल तर तुमचा सी म्हणजेच हा तुमचा रेफरन्स पॉइंट आहे आणि तुमचा एक्स बार हा डायरेक्ट हा सी पर्यंतचा आहे आणि तिसऱ्या सेक्शनचा पण एक्स बार हा सी पर्यंतचा. So for that purpose we have to read the statement carefully and we have to check at which point we have to calculate the unknown parameters. Okay, now you are able to go for the BM calculation, you are able to go for the bending moment diagram, and after that we have to divide the BMD in the standard cases. Okay, now we'll calculate the slope. So first, slope at which they have asked, what I have given, find the slope and deflection at free end. Okay, so slope at B, so here YB. Okay, so what is our formula? Theta B is equal to A upon ER. So how many cross sectional areas are there in BMD? आता B ला काढायचं म्हणजे B च्या लेफ्ट साइडचे सगळे सेक्शन आपल्याला घ्यावे लागणार. How many section? 3 sections are there. Getting? So what I will do? I will write A1 plus A2 plus A3 divided by E upon I. So separate areas will calculate. So A1 is equal to, what is the cross sectional area of A1? Triangular section is there. So what is the formula? 1/2 H into L. So put the value 1/2 into, what is the height? What is the height of section? This vertical distance, बरोबर. हे vertical distance म्हणजे तुमची height आहे. हे height म्हणजे किती point आहे हा? 180 into 10 raised to 6. Don't take the negative sign. Getting? So 180 into 10 raised to 6 into, what is the length? 3 meters. So we have to take in mm. So it is equal to 3000. So do the calculation. Similarly, A2 is equal to H into L. This is the formula for the rectangular section. So what is the height of this section again? हा बघा, हा रेक्टँगल आहे एवढा. याची हाईट किती आहे? हा पॉइंट म्हणजे इकडचा पॉइंट आहे, बरोबर. So this is the length and this is the height. So H is equal to, once again, 180 into 10 raised to 6 into length 3000 is equal to, and last area A3 is equal to, once again, 1/2 into H into L. So 1/2 as it is into height. What is the height of third section? What is the height of? No, this is the height of 480. हे point A पासून इथपर्यंत डिस्टन्स आहे. 300. मग ह्या टोटल, फॉर एक्झाम्पल हा आपण पॉइंट P म्हणूया. AP डिस्टन्स तुमचं किती आहे? 480 into 10 raised to 6. आपल्याला काढायचं कुठलं? PQ फॉर एक्झाम्पल. मग ह्या मोठ्या हाईट मधून जर AQ एवढं डिस्टन्स जर आपण सबस्ट्रॅक्ट केलं तर राहिले किती? म्हणजे काय केलं? 480 मधून जर 180 जर वजा केलं तर राहिले किती? 300. समजा बाय मिस्टेक आपण कुठलं डिस्टन्स घेतो? 400. पण आपला तेवढा मोठा ट्रायंगल आहे का? आपला ट्रायंगल कुठून सुरू झालाय? इथून इथपर्यंत. So you have to represent this distance 300 into 10 raised to 6 on the figure also. That's why I have mentioned here. Where I have mentioned? No, on the figure only I have mentioned, that is 480 minus 180. It is equal to 300 into 10 raised to 6. So take this distance. So 300 into 10 raised to 6 into length 3000. So do the calculations and tell me the answers. What is the area A1? 2.7 into 11. It is mm square. What is the area A2? 5.4 into 10 raised to 11 mm square. The first one is a 2.7 into 10 raised to 11, second 5.4, and third one 4.5 into 10 raised to 11 mm square. So these are the three cross-sectional areas which we have to consider in the theta calculation. But because for the theta only area is important, x bar distance are not important. So do the calculation of all the cross-sectional areas. and then put all the values in the theta equation. That is theta b is equal to, so area A1 2.7 into 10 raised to 11 plus 5.4 into 10 raised to 11 plus 4.5 into 10 raised to 11 divided by E into I, whether it is given, just 4 into 10 raised to 30. So theta b is equal to 0.31. What is unit? Radian. So 0.031 into 180 by pi. So you will get in degree 1.80 degree. So this is your final. If you check the slope value, it is very small. It is near about 1 or 2 degree. That means very small amount of slope is there. So like that, we have to go for the calculation. If you will get the number of cross-sectional areas under BMD. So we have to divide the BMD in standard sections only. Either triangle, either rectangle, then parabolic curve. In that second degree of parabola, third degree of parabola, like this. So this is the slope at point B. Now, if I have to calculate the slope at point C, so what I will do? Theta C is equal to, what is my formula? If I have to calculate the slope at point C, theta C is equal to A upon EI. This is a standard formula, which is equal to, which two areas I have to consider? A2 plus A3. So, because at the left side of the point C, only section 2 and 3 is present. So, in that case, effect of section 1 we have to not consider. Getting? So write down few lines in your notebook at the top. So write down, for cantilever beam, while calculating slope and deflection, at particular point म्हणजे कुठला पण आला, getting? तो फ्रेंडचा असू द्या किंवा मिडलचा कुठला पण असू द्या, at particular point consider all the sections under BMD, which are present at left side of that particular point, Okay. Now theta b is calculated. Theta b काढण्यासाठी आपण तिन्ही सेक्शन कन्सिडर केले. theta c काढण्यासाठी फक्त दोनच. मग कुठल्याची बेरीज करणार तुम्ही? फक्त दोन क्रॉस सेक्शन एरिया. कुठले 5.4 into 10 raised to 11 आणि 4.5 into 10 raised to 11, त्याला divided by e into I करणार. You will get the slope value at theta c. Getting? Now deflection at point B. So here YB. Here write down, consider point B as a reference point for X bar calculations. Okay, so first of all, I will write on the basic formula. YB is equal to AX bar upon EI. So here I have to write down the formula in the form of in the form of 3 sections. So how I will write this? A1 x1 bar plus A2 x2 bar plus A3 x3 bar divided by E upon. So don't put the formula directly in this equation. Getting? Don't put the formula directly in this final equation. Try to calculate x1 x1 bar x2 bar x3 bar separately. So here where x1 bar is equal to. So which section is there under section 1? Triangular section is there. For the triangular section, what is formula? I have written on the figure also. 2 by 3 into length of BC, correct? So 2 by 3 into 3000, which is equal to. Similarly, x2 bar is equal to L of AC divided by 2. हा फक्त सेक्शन 2 साठीच ऍप्लिकेबल आहे, बरोबर. L of AC divided by 2. आपण असं म्हणू शकत नाही की आपल्याला हे एक्स बार डिस्टन्स पॉइंट बी पासून घ्यायचंय, म्हणून हे टोटल दिस 3 मीटर प्लस दिस 1.5 मीटर डिवाइडेड बाय 2 असं आपण करू शकत नाही. L by 2 it is applicable for section 2 only. So remaining distance we have to write as it is, that is L of BC. So 3000 divided by 2 plus 3000, because point B is your reference point. Similarly, x bar 3 is equal to again 2 by 3 into L of AC plus L of BC, which is equal to 2 by 3 into 3000 plus 3000. Understand why 3000 is added for section 2 and 3, because B is your reference point. त्यामुळे x bar काढण्यासाठी राहिलेले दोन डिस्टन्स as it is आपल्याला ऍड करावे लागणार. So what will be the first x1 bar distance? 2000. Please check your answers and send the answers in the chat box. 2000 mm. This is the x1 bar. 4500 mm. 5000 mm. So these are the three CG points of the all particular sections. Very simple to calculate. If you are not adding the 3000, your answer will be wrong. If you are not adding the remaining 3000, that's why I have written one sentence: consider point B as a reference point for x bar calculation. This sentence is very, very important. Now put the values in the final equation. You will get the final answer. YB is equal to, so A1 is equal to 2.7 into 10 raised to 11 into 2000 plus 5.4 into 10 raised to 11 into 4500 plus 4.5 into 10 raised to 11 into 5000 divided by 4 into 10 raised to 30. So deflection at point B. So do the calculation. Okay, 130.5. Please check your answer. 130.5 mm. This is the deflection at point B. 130.5. Do the calculation properly. It is very simple. Apply the brackets wherever it is necessary. 130.5. This is the deflection at point B. This is the deflection at point B. This is the deflection at point B. That means free end deflection is there. Someone's mic is on. Please mute yourself. Roll number 16.
मीच नोटबुक
Please mute yourself. Sakshi More. Please mute yourself.
नोटबुक मध्ये लिहिले अर्धा काय बाई अगं बाई
Sakshi More, your mic is on. Okay, now we have selected point B as a reference point, correct? Now, if I have to calculate the deflection at point C, if I have to calculate the deflection at point C, so how many sections are present? 2. मग तिथे आपण स्लोप काढताना 2 एरिया घेतले, getting? तसं मग डिफ्लेक्शन काढताना पण आपल्याला किती एरिया घ्यावे लागतील? 2 एरिया घ्यावे लागतील. मग कुठे चेंज होईल आपल्या याच्यामध्ये? मग जर मला 2 आणि 3 क्रॉस सेक्शनल एरिया मध्ये काय चेंज होणार आहे का फॉर्म्युलेमध्ये? नाही. मग डिफ्लेक्शन काढताना which parameter will get changed? Which parameter will get changed? x2 bar and x3 bar. मग जर फॉर्म्युला आपण असं लिहिला काय? yc is equal to a2 x2 bar plus a3 x3 bar divided by e into I. मग ही x2 bar आणि x3 bar ची व्हॅल्यू मी प्रिव्हियस कॅल्क्युलेट केलेली घेऊ शकतो का? Why? कारण हा x2 bar आणि x3 bar हा पॉइंट B as a reference point consider करून केलेल्या व्हॅल्यू आहे. But for the calculation of C, these values will not be applicable. In the figure, for the deflection calculation at point C, directly I am taking this x2 bar distance up to the point C only. म्हणजे काय येणार? L divided by 2. राहिलेलं 3000 ऍड करायची गरज आहे का? नाही. सिमिलरली थर्ड सेक्शन साठी 2 divided by 3 into length AC. परत ह्याच्यामध्ये 3000 ऍड करायची गरज आहे का? No. So we have to check the point. Sometimes what mistakes we are doing? They have asked to calculate the point C also. मग आपण काय करतो? ऑलरेडी x2 बार आणि x3 बार काढलेला आहे. याच व्हॅल्यू आहे अशा आपण ह्या इक्वेशन मध्ये काय करतो? But that calculation becomes wrong and your yc distance is yc deflection value is also becomes wrong. So you have to do the calculation of x bar again and again as per the requirement. एरियाच्या व्हॅल्यू मध्ये काही चेंज होणार नाही, पण एक्स बारच्या व्हॅल्यू मध्ये जर तुमचा पॉइंट चेंज झाला तर त्याच्या ठिकाणी मात्र तुमच्या एक्स बारच्या व्हॅल्यू 100% काय होणार आहे? चेंज होणार. अंडरस्टूड? गेटिंग? ओके. नाउ one problem I will give for the homework. Write down the statement. One problem I will give for the homework. Find slope and deflection at free end. Find slope and deflection at free end for cantilever beam. For cantilever beam. For cantilever beam having length 3 meter. Having length 3 meter. Carrying UDL of 5 kilonewton per meter. Carrying UDL of 5 kilonewton per meter of span 1 meter. Of span 1 meter from fixed end of span 1 meter from fixed end, full stop. Use moment area method. Use moment area method, full stop. Take E into I. Take E into I is equal to 2 into 10 raised to 13. 2 into 10 raised to 13 Newton mm square. Understood the statement? Cantilever beam total length किती आहे? 3 मीटर. UDL ची मॅग्निट्यूड किती दिले? 5 kilonewton per meter on span. Whether it is under standard case? Whether it is under standard case? No.
No, sir.
Why? UDL is not spread on entire span. बीम ची लेंथ आहे 3 मीटर. 3 मीटर UDL सांगितलंय का? किती सांगितलंय? 1 मीटर फ्रॉम फिक्स्ड एंड. ज्या बाजूला फिक्स आहे त्या फिक्स एंड पासून 1 मीटर वरच फक्त तुमचं UDL आहे. राहिलेलं 2 मीटर बीम कसं आहे? फ्री आहे. Getting? Are you able to go for the BM calculation? You have to draw the BMD. Getting? And you have to go for the calculation. आता हेच तुम्हाला समजलं पाहिजे. या ठिकाणी UDL आहे म्हणजे या ठिकाणी तुम्हाला इन्क्लाइन्ड लाईन मिळणार नाही. You will get one curve that is 3rd degree of parabola. म्हणजे त्याची प्रॉपर्टी तुम्हाला माहिती आहे. Getting? त्याची प्रॉपर्टी तुम्हाला माहिती आहे. 3/4 किती आहे? सगळ्यात शेवटची प्रॉपर्टी 3/4 into length. आणि त्याचा एरिया काय? 1/3 into h into L. Okay, you should do the calculations and send me the answer in the Canada file. Okay, now one problem we'll take on the simply supported beam. So these are the problems for the cantilevers. Getting? So maximum means 99% problems are there where your BMD will be generated in either negative or either positive. जर आपण साइन कन्व्हेन्शन उलटी घेतली तर हीच बेंडिंग मोमेंट डायग्राम तुमची पॉझिटिव्ह रिजन मध्ये जाईल. आपण साइन कन्व्हेन्शन निगेटिव्ह घेतल्यामुळे तुमची बेंडिंग मोमेंट डायग्राम कुठे आले? निगेटिव्ह पोर्शन मध्ये आले. ठीक आहे. नाउ विल सी द मोमेंट एरिया मेथड फॉर द सिम्पली सपोर्टेड बीम. Okay, so I will give the statement. Write down. A simply supported beam 5 meter long. A simply supported beam 5 meter long carries 10 kilonewton load at midpoint. Carries 10 kilonewton load at midpoint. Full stop. Calculate by moment area method. Calculate by moment area method. Slope at supports. So slope at supports and deflection at midspan. And deflection at midspan. Full stop. Take capital E is equal to 2 into 10 raised to 5 Newton per mm square. And I is equal to capital I 1 into 10 raised to 6 mm raised to 4. आताच्या सगळ्या प्रॉब्लेम मध्ये आपल्याला E into I डायरेक्ट फ्लेक्चरल रिजिडिटी दिली होती. त्याचं युनिट कसं आहे बघा? न्यूटन mm स्क्वेअर. मिळते का न्यूटन mm स्क्वेअर युनिट? मिळते का याच्यामध्ये बघा? E into I बघा काय इथं? E into I. E चं युनिट काय असतं? न्यूटन पर mm स्क्वेअर. I चं काय असतं? mm रेस टू 4 डिवाइडेड बाय 1. मग इथलं mm स्क्वेअर आणि इथलं एक mm स्क्वेअर गेलं, राहिलं काय? न्यूटन इंटू mm स्क्वेअर. सो दिस युनिट विल बी आस्क्ड फॉर द 1 मार्क. Getting? What is the unit of flexural rigidity? Or flexural rigidity म्हणजे काय असतं? E into I, E into G, G into K. Like that, options will be given. From that, you have to choose correct one. Getting? So the problem is given on the simply supported beam. So draw the figure first. So simply supported beams, it is supported at point A, it is supported at point B. The total length of the beam is 5 meter. Total length of the beam is 5 meter, subjected to the point load at point C of 10 kilonewton. Leave some space below the loading diagram to draw the bending moment diagram. So this is the figure. So this is 2.5 meter. This is of 2.5 meter. So this is under standard case. Getting? This is under the standard case. We are having the direct formula also. What is the formula for this case? What is the formula for this case? WL काय? WL square upon 4. Bending moment formulae. WL by 4. What is the value of W? Okay, what is the length? Divided by WL by 4. What is that answer? Convert all the parameters in mm. 10 into 10 raised to 3 into 5000 divided by 4. 12.5 into 10 raised to 6. This is our answer. बरोबर हे आपण व्हेरीफाय केलं फक्त. पण इथं आपण ते डायरेक्ट आन्सर लिहू शकतो का? This is the movement area method. So we have to go for the BM calculation. Separate mark आहेत BM calculation ला 2 मार्क. तुम्ही जर डायरेक्ट लिहिलं तर त्याचा अर्थ असा झाला तुम्ही पाठ केले तुम्ही ते तिथे लिहून आला. We have to follow the procedure. Bending moment calculation केलं नाही आणि तुम्ही डायरेक्ट जर bending moment diagram ड्रॉ केली तर कशी काढली? Getting? So we have to go for the BM calculation at least for the moment area method. So here we cannot calculate the direct BM. First of all we have to calculate the reactions. बरोबर आहे? मग रिएक्शन कॅल्क्युलेट करू शकतो का इथं? सांगा किती येतील रिएक्शन? The force which is moving in downward direction. How many forces are there? One. It is moving in magnitude 10 kilonewton. We are having standard. The forces which are moving in downward direction is equal to forces which are moving in upward direction. आता वर येणारे forces किती आहेत? 2 आहेत. रिएक्शन RA आणि रिएक्शन RB. आणि हा पॉइंट लोड बरोबर सेंटरला ऍक्ट झालेला आहे. त्यामुळे रिएक्शन RA is equal to 5 kilonewton and RB is also equal to 5 kilonewton. If you are not able to calculate, apply our procedure. Reaction calculation. Reaction calculation. Summation of vertical force is equal to 0. So I will start from the left side. RA minus 10 plus RB is equal to 0. Therefore, RA plus RB is equal to 10 kilonewton. Correct? This is equation number 1. वर जाणारे फोर्सेस आपण पॉझिटिव्ह घेतले, खाली येणारे फोर्सेस निगेटिव्ह. बट हियर 2 अननोन्स आर देयर. RA पण अननोन आहे आणि RB पण अननोन आहे. मग काय करायचं? एका कुठल्या तर सपोर्टला आपण मूवमेंट काय करतो? 0 घेतो. मग व्हॉट आय विल डू? समेशन ऑफ MA is equal to 0. मग आता ह्या पॉइंटला जर आपण 0 घेतले असतील तर ह्याच्या राईट साइडला किती फोर्सेस राहिले? 2. एक म्हणजे पॉइंट लोड आणि दुसरी म्हणजे रिएक्शन. पॉइंट लोड कसा रोटेट होतोय? क्लॉकवाइज. आणि रिएक्शन कशी रोटेट होते? anti-clockwise. So what I will do, 10 into 2.5 minus RB into 5 is equal to 0. किती येते RB? येते का 5 किलोन्यूटन बघा. येते? Then your RA plus 5 is equal to 10. Therefore, RA also equal to 5 kilonewton. If you write directly, no problem. If you are unable to go for the direct calculation or direct writing, you have to follow this procedure. Summation of vertical forces is equal to 0. पण आपल्याला स्टँडर्ड माहित पाहिजे, एवढी कॅल्क्युलेशन करायची गरज नाही. So these are the reactions calculation. So many times we have followed this procedure in your SFD and BMD. Okay, so this is the reaction calculation. Now go for the BM calculation. BM calculation. Now for the simply supported beam, what is the sign conventions? From where we are starting the BM calculation from the simply supported beam? Whether left side or right side? Left side. So here start from left side. What is the sign conventions? Clockwise movement and anti-clockwise movement. What is the sign for the clockwise? Positive, and it is negative. So start from the left side. BM at A is equal to A च्या left side ला काय forces आहेत का? नाही. So it is equal to 0 kilonewton meter. BM at C. How many forces are there? BM at point C. Point C ला काढतो आपण. There is only one force. What is that? 5 into 2.5 equal to
12.5.
12.5 kilonewton meter. And last BM at B किती येणार आहे? 0. जरी तुम्ही कॅल्क्युलेट करून बघितलं तरी पण किती येते? 0 येते. Now here 12.5 into 10 raised to 6 Newton mm. स्टँडर्ड फॉर्म्युला वापरून मग अशा प्लान किती आलं होतं? WL/4 चा वापर करून आलं का एवढं बघा. W 10 into 10 raised to 3, L 5000 divided by 4. किती येते आन्सर बघा?
12.5 into 10 raised to
12.5 into 10 raised to 6 Newton mm. We can use either direct formula or we can follow this procedure. But as this is the movement area method, there is a separate marks for the BM calculation. So we have to do the calculation like this. So BM at A 0, BM at B 0, and BM at C. It is maximum bending moment point, correct? A ला पण 0 आहे आणि B ला पण 0 आहे, तर C ला काय झाला तो maximum झाला. So you have to draw the figure. So this is your horizontal line. This is your point A. This is the center point C. This is the another point B. So bending moment at point A 0, bending moment at point B 0, and bending moment at point C 12.5 into 10 raised to 6. How to join these 2 points? Inclined line, correct? ह्या ठिकाणी उडेला असता तर हा कर्व आला असता, but here point load is there, therefore this is inclined line. And from this point I will draw one dotted line. Getting? Due to this, my bending moment diagram will be divided into the two triangular sections. This is section 1, this is section 2. आता ह्याचा x bar काय असणार आहे? 2.5 मीटर 2.5 मीटर. आता पॉइंट ए ला मला काढायचं म्हणजे पॉइंट ए काय झाला तुमचा? रेफरन्स पॉइंट झाला, म्हणजे हा झाला x बार इज इक्वल टू 2/3 इंटू लेंथ. तसंच इकडं x बार इज इक्वल टू 2/3 इंटू लेंथ. मला थीटा ए काढायचा असेल त्यावेळेस मी सेक्शन 1 घेणार, आणि थीटा बी काढायचा असेल तर मी सेक्शन 2 घेणार. बट this is standard case, so whatever the answer you will get for the theta A, same answer will be applicable for the theta B. कारण ह्या ट्रायंगल मध्ये ह्या ट्रायंगल मध्ये काय फरक आहे का? याची पण हाईट तेवढीच आहे, याची पण हाईट तेवढीच आहे. याचं पण खालचं डिस्टन्स 2.5 मीटर आहे, याचं पण खालचं डिस्टन्स 2.5 मीटर. त्यामुळे तुम्ही थीटा A काढला तर इवर थीटा A इज इक्वल टू थीटा B. गेटिंग? जसं आपण डेरिव्हेशन मध्ये प्रोसेस फॉलो केली तीच प्रोसेस आपल्याला फॉलो करायची. Getting? Now figure is drawn. Now go for the calculation. What they have asked? Slope at support and deflection at mid span. Cantilever beam मध्ये स्लोप आणि डिफ्लेक्शन दोन्ही पण व्हॅल्यू फ्रेंडला मॅक्सिमम होत्या, आणि दोन्ही पण व्हॅल्यू फिक्स्ड एंडला 0 असतात. तर सिम्पली सपोर्टेड मध्ये तसं आहे का? नाही. स्लोप इज मॅक्सिमम ॲट सपोर्ट and deflection is maximum at center point or mid span. So use the first formula, that is third one. Slope at supports theta A and theta B. So theta A is equal to, what is the formula? A upon EI. So what is the area? 1/2 into h into length divided by E into I. So 1/2 as it is into height 12.5 into 10 raised to 6 into length. Length of only one section. आपण कुठल्या एरियासाठी घेतोय? फॉर एक्झाम्पल 2500 divided by 2 into 10 raised to 5 into 1 into 10 raised to 6. तर ह्या ठिकाणी जे आपण एरिया घेतलाय, राईट डाउन एरिया इन सेक्शन AC. बाय मिस्टेक्स वी आर टेकिंग द लेंथ 5 मीटर, पण 5 मीटर लेंथ घेऊन चालेल का आपल्याला? नो. सो थीटा A is equal to 0.078 radian. So 0.078 into 180 by pi, which is equal to 4.476 degree. Therefore, theta A is equal to theta B is equal to 4.476 degree. This is the slope at the supports. Both values are same. So we are not required to go for the double calculation of theta B. Directly we can write theta A is equal to theta B. So this is the slope value. Then go for the deflection. So fourth one, deflection at point C, that is YC. So YC is equal to A x bar upon EI. So 1/2 into H into length into x bar 2/3 into length of, I will consider AC, divided by E into I. So 1/2 into 12.5 into 10 raised to 6 into 2500 into 2/3 into 2500 divided by 2 into 10 raised to 3 into 1 into 10 raised to 6. So deflection at point C. 13.0 into 10 raised to 3. So it's 10 raised to 5 है ना. 2 into 10 raised to 5 है ना, बरोबर. E is equal to 2 into 10 raised to 5. Yes, 130.20. 130.20. So what is your answer? 65.10. No, 130.20 mm. Please check your answer. 130.20. So in the numerator side, there is also one dividing factors are there. That is 2 is also dividing, 3 is also dividing. 132.2. This is correct. Please do the calculation here. 13.02 into 10 raised to 3. This is wrong. Do the calculation once again. Send me the correct answer. Please check. In the numerator side also there is a 1/2 is there, 2/3 is there. So do the calculations properly at the numerator side. And then you have to divide the total answer by E into I. That's 132.2. Okay, so this is the problem for the simply supported beam. Getting procedure? समझ लें? So whatever the procedure we have followed for the derivation, same procedure we have to follow. Getting? And mostly for the simply supported beam, your bending moment diagram will be in positive region. Getting? त्याच्यामध्ये फक्त तुम्हाला दोन शेप मिळतील, एक म्हणजे इन्क्लाइन लाईन आणि दुसरा म्हणजे असा वर येणारा पॅराबोलिक कर्व. त्यामुळे त्याची प्रॉपर्टी वेगळी आहे बघा. तुम्हाला कर्व कशा फॉर्म मध्ये मिळतात? In cantilever, in simply supported, you will get like this. बरोबर? त्याची प्रॉपर्टी वेगळी आहे. आणि कॅन्टिलिव्हर मध्ये कसं मिळतं तुम्हाला कर्व? लाईक दिस. दोन्हीची फॉर्म्युला सेम आहेत का? Properties are different. Okay, so follow these particular sections for the respective beams and use the formulas. Okay, so this is about the moment area method. Understood the procedure? So whatever the procedure we have followed for the derivation purpose, same procedure we have followed for the solving the numericals. First step, we have to go for the BM calculation. Then we have to draw the bending moment diagram. In bending moment diagram, we have to check the cross-sectional areas. कुठले कुठले क्रॉस सेक्शनल एरिया त्याच्यानुसार त्याच्या एरियाचे फॉर्म्युले घ्या, त्याच्या प्रॉपर्टी एक्स बार चे फॉर्म्युले घ्या. अँड वी हॅव टू पुट इन द इक्वेशन ए अपॉन EI आणि AX बार अपॉन EI. अंडरस्टूड? मोमेंट एरिया मेथड समजले काय आहे की? ओके, सो दोज हु आर अटेंडिंग ऑनलाइन हैव अंडरस्टूड moment area method, their derivations and their numericals.
Yes,
one problem I have given for the exercise for the cantilever beam that you have to solve. Okay, everyone have understood? Any problem you can ask. Okay, so with this we have finished this particular moment area method where we are having both derivations as well as problem also. One statement they have mentioned in the your syllabus, that is when Maculus method is there. Getting one content is there, that Maculus method. By using the Maculus method also we can solve the numericals, but it is not your syllabus. Just we are having the introduction part of the Maculus method. What is the difference between? Actually, there are three methods. By using we can calculate the slope and deflection. First one is the moment area method, which we have discussed. Second one is the Maculus method, and third one is a double integration method. So these are the three standard methods of the slope and deflection. By using we can calculate the slope and deflection. And ती कुठल्या जरी मेथड ने तुम्ही एखादा प्रॉब्लेम सॉल्व केला तर तिन्ही मेथड ना आलेला आन्सर काय असणार आहे? सेम असणार आहे. Only procedures are different. But as per your syllabus, you are having the introduction part of Maculus method, so that we will discuss at the end. But still, you are having some another numericals. Now, this is the movement area method. ज्याला आपण graphical method पण असं म्हणू शकतो. बरोबर, आपण एक बेंडिंग मोमेंट डायग्राम ड्रॉ करतो म्हणजे ते ग्राफिकल मेथड आहे. आणि बाय युजिंग दॅट ग्राफिकल मेथड वी आर सॉल्विंग द न्यूमेरिकल. जसं आपण प्रिन्सिपल स्ट्रेसेस आणि स्ट्रेन मध्ये बघितलं होतं, मोर सर्कल मेथड म्हणजे एकच प्रॉब्लेम पण मोर सर्कल पण सॉल्व केला आणि डायरेक्ट लिस्ट ऑफ फॉर्म्युला पण सॉल्व केला. दोन्हीचे आन्सर आपण व्हेरीफाय केले होते. बरोबर, आपले आन्सर सेम होत होते. तसंच स्लोप अँड डिफ्लेक्शन मेथड मध्ये पण तुम्हाला न्यूमेरिकल एकतर मोमेंट एरिया मेथड ते सांगतात सॉल्व बाय द मोमेंट एरिया मेथड. आता हाच फॉर्म्युला किंवा आताचाच हा प्रॉब्लेम, दिस प्रॉब्लेम वी कॅन सॉल्व बाय युजिंग द एनालिटिकल मेथड ऑल्सो. आता ह्याच्यासाठी तुम्हाला स्लोप अँड डिफ्लेक्शनचा फॉर्म्युला माहिती आहे. व्हॉट इज द स्लोप फॉर्म्युला? वी हॅव डिराइव्ड दॅट फॉर्म्युला. फर्स्ट डेरिवेशन WL square upon, please check. Maybe it is correct, but check once again. WL square upon 16 AI. बरोबर, दिस इज द फॉर्म्युला. आहे का फॉर्म्युला आपल्या डेरिवेशनचा? आणि व्हॉट इज द डिफ्लेक्शन फॉर्म्युला? WL cube upon 48 EI. डिफ्लेक्शनचा फॉर्म्युला आहे का केस नंबर 1 साठी? WL cube upon 48 EI. म्हणजे हे दोन फॉर्म्युले वापरून पण आपण हा मोमेंट एरिया मेथडचा प्रॉब्लेम सॉल्व करू शकतो. किती स्टेप मध्ये उत्तर येईल? मोजून 4. स्लोपचा फॉर्म्युला यूज करा. W ची व्हॅल्यू दिलेली आहे, लेंथ दिलेली आहे, E into I दिलेला आहे. दुसऱ्या स्टेप मध्ये उत्तर येणार. तसंच डिफ्लेक्शन W दिलेला आहे, L दिलेला आहे, E into I दिलेला आहे. डिफ्लेक्शन आन्सर सेमच येणार. बट वी हॅव टू चेक द स्टेटमेंट केअरफुली. जर त्यांनी सॉल्व बाय द मोमेंट एरिया मेथड जर विचारला असेल आणि तुम्ही तो प्रॉब्लेम हे डायरेक्ट फॉर्म्युला घेऊन जर सॉल्व केला, तुमचे आन्सर बरोबर असतील, बट देयर इज अ चान्सेस ऑफ 0 मार्क. तुम्ही फॉर्म्युला बरोबर लिहिलाय, तुमचा आन्सर बरोबर आहे, म्हणून तो एक्झाम मध्ये तुम्हाला 1 किंवा 2 मार्क देईल. यांनी चांगलं सोडवलंय म्हणून आन्सर बरोबर आहे. पण तुमचे 8 मार्क त्या ठिकाणी जाणार. 8 पैकी तुम्हाला किती पडतील? 1 किंवा 2. सो यू हॅव टू रीड द स्टेटमेंट केअरफुली. समजतंय? हाऊ सच प्रॉब्लेम्स आर आस्क्ड, दॅट सॅम्पल विल सी नाउ. हे प्रॉब्लेम कसे विचारले जातात, आपल्याला मोमेंट एरिया मेथड कुठे वापरायचे ते तुम्हाला समजले. आता आतापर्यंत सगळे प्रॉब्लेम बघितले आपण, प्रत्येक स्टेटमेंट मध्ये यूज मोमेंट एरिया मेथड असं सांगितलं. मग एनालिटिकल मेथड ने कसे सॉल्व करायचे तर दॅट विल डिस्कस. ओके, वी विल सॉल्व सम सॅम्पल 2-3 प्रॉब्लेम्स अँड देन वी फिनिश द न्यूमेरिकल पार्ट. ओके, सो दिस इज द लिस्ट. जे फॉर्म्युला मी तुम्हाला डेराइव्ह करून दिलेले आहे तीच लिस्ट इथे आहे. सो वेदर इट इज रिक्वायर्ड टू टेक इट सेपरेटली. इज इट रिक्वायर्ड? यू कैन टेक दिस सेपरेटली, कारण प्रत्येक वेळेला फॉर्म्युला आठवण्यासाठी प्रत्येक डेरिव्हेशन बघणं आपल्याला शक्य नाही. ओके, सो टेक दिस पर्टिक्युलर लिस्ट. Slope and deflection formulae for the simply supported beam. Make the 4 columns. Serial number, type of beam, with type of load, slope formula and deflection formula. So this is the list you have to keep in your mind, and you have to remind these formulas. Make the 4 columns. Draw the figure also, because according to type of beam and type of load, you will understood through figure. These 8 formulas are required for your MCQ also. बऱ्याच वेळा स्लोप अँड डिफ्लेक्शनचे MCQ तुम्हाला विचारले जातात फॉर्म्युले. कंडिशन दिली जाते स्टेटमेंट मध्ये. Simply supported beam subjected to the UDL on entire span. What is the deflection formula? मग त्या ठिकाणी तुमचा तो फॉर्म्युला लक्षात असला पाहिजे. 5WL raised to 4/384 EI. 4 ऑप्शन वेगवेगळ्या फॉर्म मध्ये दिले जातात. Okay, finish. Have you written for simply supported? And now slope and deflection formula for the cantilever beam. Again, the two standard cases, point load and the UDL. There is a possibility of confusion in L square, L cube, or some multiplying factor at the denominator side. 2 EI, 3 EI, 6 EI. Okay, finish. Okay, we'll solve some 2-3 numericals. How some sample problems they are asking, that is without moment area method, how to solve the problems. That will understood. Okay. So this is the first statement. So we have to read the statement carefully. A beam 6 meter long, simply supported at its end, is carrying point load. Total length of the beam is 6 meter. Type of beam is also mentioned, simply supported, and it carries a point load at its center of 50 kilonewton. The moment of inertia is given by 78 into 10 raised to 6. If E of the material is equal to 2.1 into 10 raised to 5 Newton per mm square, calculate deflection at center and slope at support. So this is the statement. But in the statement, they have not mentioned the word moment area method. Getting? आता ह्या ठिकाणी जर तुम्ही moment area method जर apply केली, you will get the answer. Getting? But your procedure becomes lengthy. बरोबर? BM calculation करा, त्याच्यानंतर बेंडिंग मोमेंट डायग्राम ड्रॉ करा, मग स्लोप अँड डिफ्लेक्शनचा फॉर्म्युला यूज करा. आन्सर येतील. इट विल टेक मच मोर टाइम. पण ही स्टँडर्ड केस आहे. स्टँडर्ड केससाठी आपल्याला फॉर्म्युला आहे. विदिन 2 to 3 steps you will get the final answer. So think about the statement carefully and apply the solution. जर तुम्हाला फॉर्म्युला आठवत नसतील, मोमेंट एरिया मेथड हा प्रॉब्लेम सॉल्व करा, you will get the answers. त्या ठिकाणी मात्र तुम्हाला 8 पैकी ऍटलीस्ट 7 किंवा 6 मार्क मिळतील. पण मोमेंट एरिया मेथड विचारला असेल तर जर तुम्ही तो डायरेक्ट फॉर्म्युला जर सॉल्व केला तर त्या ठिकाणी मात्र तुम्हाला मार्क कमी मिळतील. पण विचारले अनालिटिकल मेथडनी, पण त्या ठिकाणी तुम्ही अनालिटिकल मेथड अप्लाय करा किंवा मोमेंट एरिया मेथड अप्लाय करा, यू विल गेट द मार्क्स. डोंट वरी अबाउट इट. Okay, so first of all draw the figure, that is simply supported beam. So simply supported beam which is supported at two support, that is point A, B, subjected to the point load of 50 kilonewton. Okay, so here their deflection will be taking place like this. This is point C. The total length of the beam is 6 meter. So this is theta A, this is theta B, and at the center there is a YC. So here write down all the given parameter first. So the value of W, so length is given 6 meter is equal to 6,000. W is given 50 kilonewton, which is equal to 50 into 10 raised to 3 Newton. Moment of inertia means your I value 78 into 10 raised to 6 mm raised to 4. E 2.1 into 10 raised to 5 Newton per mm square. Calculate deflection at center YC, and slope at supports means theta A is equal to theta B, which is equal to question mark. Here also your theta A is equal to theta B, because point load is at the center. All the given parameters are given. Directly we have to remind the formula. Slope at supports, that is theta A and theta B. So theta A is equal to theta B. So what is the formula for this case? WL square upon 16 EI. So WL square upon 16 EI. So W 50 into 10 raised to 3 into L 6,000 square divided by E 2.1 into 10 raised to 5 into 78 into 10 raised to 6. So theta A is equal to theta B. In radian you will get the first answer. What is the answer? 0.0. Zero point 0.01. We check the answer. 15 to 10 raised to 3 into 6,000 square. Sometimes what happen? We are not making the square of 6,000. WL square upon 16 EI. First of all, tell me the answer of radian. 6.86 into 10 raised to minus 3. Let's check. 6.86 into 10 raised to minus 3. This is radian. Please check your answer. WL square upon 16 EI. So here I forgot to write down the 16. बरोबर आहे. Don't follow me 100%. Sometimes I am also making the mistake. So you have to think about that whether I have written correctly or not. So divided by 16 into E into I. Are you getting 6.86 into 10 raised to minus 3? Getting? Now we have to multiply by theta A is equal to theta B is equal to 6.86 into 10 raised to minus 3 into 180 divided by pi. So theta A is equal to theta B is equal to 0.039 degree. Correct. To check in radian, you will get 8.68 into 10 raised to minus 3. It is in radian. And for that radian, you have to multiply by 180 by pi. You will get the slope in degree as a 0.39 degree. And then deflection at center, that is YC. So what is the formula? YC is equal to WL cube upon 48 EI. So here W once again 50 into 10 raised to 3 into L cube means 6,000 cube divided by 48 into E 2.1 into 10 raised to 5 into 78 into 10 raised to 6. So YC is equal to how much? 13.73 mm. So this is the deflection at the center point and the slope at the supports. If you solve this problem by using the moment area method, that answers will be near about this. And जरी हा problem तुम्ही जरी moment area method ने जरी solve केला, you will get some marks, at least 5-6. But moment area method ने विचारल्यानंतर तुम्ही त्या ह्याने solve केला, you will get 1 or 2 marks. Just you have solved it correctly due to this only. But instead of applying the moment area method here, you can remind the formula and you can put the values and you will get the answer. Please check. Deflection is equal to 13.73. Deflection is equal to 13.73 and slope is equal to 0.39 degree. Okay. The next. So the problem is somewhat different. Read the statement carefully. A beam of length 5 meter and uniform rectangular section is supported at its end and carries UDL over entire length. Calculate depth of the section if maximum permissible bending stress is 8 Newton per mm square. The center deflection is not to exceed 10 mm. Take E is equal to 1.2 into 10 raised to 4. The beam of length 5 meter and uniform rectangular section is supported at two ends. Means which type of beam is there? It is supported at its two ends. Kutla beam asta pahiye mad? Simply supported. So here the simply supported beam is there and it carries UDL on entire span. Okay, so accordingly you have to draw the figure first. So this is the beam which is supported at the two ends, that is A, B. Total length of beam 5 meter. It is subjected to UDL on entire span. Whether value of UDL is given, it is not in the statement. The statement जर वाचलं तर त्यामध्ये UDL ची लोडची मॅग्निट्यूड तुम्हाला दिलेली नाही. So we have to consider it as a W kilonewton per meter. The type of section is also given, rectangular section, correct? Type of section is also given. So this will be considered as a B and this will be considered as a D. Depth of section. Other given values you can write, that is length is equal to 5 meter is equal to 5000 mm. Then what others they have given? Bending stress sigma B is given 8 Newton per mm square. Deflection, that is Y is given 10 mm. E is also given 1.2 into 10 raised to 4 Newton per mm square. And what they have asked, calculate the depth of section, that is D. This vertical distance we have to calculate. Draw the figure. Their deflection is mentioned in the statement. So what if the deflection is taking place in the downward direction at the center? This YC is equal to 10 mm. They have given. And they have asked to calculate the depth of the section. म्हणजे beam चे dimension आपल्याला काढायला सांगितलेले. But for the calculation of this beam dimensions, how we can use our deflection formula, that we have to understand. बरोबर आहे. आपल्या डिफ्लेक्शनचा फॉर्म्युला यूज करून आपल्याला काय करायचंय, बीमचे डायमेन्शन काढायचे, म्हणजे डेप्थ ऑफ द बीम काढायचं. सो हियर वी हॅव टू अप्लाय सम स्मॉल कन्सेप्ट ऑफ बेंडिंग स्ट्रेस फॉर्म्युला. त्याने बेंडिंग स्ट्रेस दिला 8 न्यूटन पर mm स्क्वेअर. W ची व्हॅल्यू तुम्हाला दिली आहे का? मॅग्निट्यूड W is not given. So we have to calculate some unknown parameters in the form of W, and that W value we have to put in our deflection equation. Deflection चा फॉर्म्युला काय for this case? Please tell me. Simply supported beam with UDL on entire span. What is the formula of deflection? 5WL raised to 4 upon 384 EI. Correct? आणि त्याच्यामध्ये जर बघितलं तर deflection 10 mm दिलेला आहे. लेंथ दिलेलं आहे, यंग मॉड्युलस दिलेला आहे, मोमेंट ऑफ इनर्शिया आपल्याला दिलाय का, बी आणि डी चे डायमेन्शन आपल्याला दिलेलं आहे. करेक्ट. डब्ल्यू ची व्हॅल्यू दिलेली आहे का, नो. सो व्हॉट विल डू, by using the bending stress formula we'll calculate the w first and that w value we'll put in the deflection equation. So first tell me the formula as per condition given. What is the bending moment formula? Bending moment formula for the simply supported beam subjected to UDL on entire span. काय बेंडिंग मोमेंट फॉर्म्युला, WL स्क्वेअर बाय 2, WL स्क्वेअर बाय 8, WL बाय 2, WL बाय 3. त्या चार फॉर्म्युला पैकी एक कुठला फॉर्म्युला आहे? आता फॉर्म्युला पार्ट झाला पाहिजे आपला, किती वेळा आपण यूज केला, WL स्क्वेअर डिवाइडेड बाय 8. सो पुट दिस फॉर्म्युला WL स्क्वेअर डिवाइडेड बाय 8. Okay, so W, keep this W as it is. What is the length? 5000 square divided by 8. Tell me the value of m in the form of W. Okay, 3.12 into 10 raised to 6 into W. Give this as equation number 1. What I have done, by using the bending moment formula, I have calculated the moment in the form of W. Getting? Now we are having the bending stress formula. What is the bending stress formula? 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 M upon I is equal to sigma B upon Y is equal to E upon R. E upon R ची आपल्याला गरज आहे का, नाही. कुठला आपल्याला घ्यायचं, फक्त जास्तीत जास्त this one. So put the value of M. What is the M? 2.12. Write down 3.12 into 10 raised to 6 into W divided by, keep this I as it is equal to sigma B किती दिलाय, 8 Newton per mm square divided by Y. What is this Y? This Y and Y from the deflection formula is different. हा Y फक्त त्या रेक्टँग्युलर सेक्शन साठी इमॅजिन करा. आपण बेंडिंग स्ट्रेस मध्ये आपण काढतो Y, काय काढतो Y बार, Y काय काढतो तू, डिवाइड बाय 2 माहिती आहे, पण काय काढतो ते Y बार म्हणजे काय असतो? Y बार means CG of this rectangular section. काय असतो? D by 2. Why D by 2? This is the regular section. हा irregular shape आहे का? It is symmetrical about x axis. त्यामुळे त्याचा CG काय होतो, बरोबर सेंटरला कॉन्सन्ट्रेट होतो, त्यामुळे D by 2. Don't take this Y as a 10 mm. बरोबर, तो Y म्हणजे पण आपण डिफ्लेक्शन म्हणून पण दाखवतोय, हा Y म्हणून आपण CG पॉइंट म्हणून पण दाखवतोय. गेटिंग, बट बेंडिंग स्ट्रेस मध्ये हा Y म्हणजे तुमचा Y बार असतो. ओके, सो इट इज इक्वल टू D by 2. Correct? Now what I will do, I will rearrange the terms. So here I will write the equation in the form of W. Okay, so before that I will write 3.12 into 10 raised to 6 into W divided by I into 8 into 2 divided by B. Okay, now I will write my equation in the form of W. आता W मध्ये जर इक्वेशन लिहायचं असेल तर मी काय करणार सांगा, हे सगळे पॅरामीटर W सोडून हे सगळे पॅरामीटर कुठे घेणार, मी राईट साइडला घेणार. मग जे न्यूमरेटरचे आहे तिकडचे ते खाली डिनॉमिनेटरला जाणार. गेटिंग? सो व्हॉट आय विल डू, W is equal to this 16 into I divided by 3.12 into 10 raised to 6 into D. Do this calculation. 16 divided by 3.12 into 10 raised to 6. 5.12 into 10 raised to minus 6 multiply by I as it is divided by D as it is. Give this equation number 2. Equation 2 in the form of I and D. That is W value. आपण W ची value find out केली. Getting? Now, as per deflection formula. What is the deflection formula? YC is equal to 5WL raised to 4 upon 384 EI. Now put the value. YC is equal to 10. 5 into, what is the value of W? 5.12 into 10 raised to minus 6 into I divided by D म्हणजे मी खाली देतो D बरोबर मल्टिप्लाय बाहेर राहिलेला व्हॅल्यू 384 into E into I where into L raised to 4 correct 5000 raised to 4 getting काय केलं फक्त ह्या W च्या ऐवजी कुठली व्हॅल्यू पुट केले इक्वेशन 2 इन फ्रंट ऑफ दॅट राइट डाउन फ्रॉम इक्वेशन 2 त्याच्यामध्ये 5 into 12 into 10 raised to minus 6 into I ही टर्म न्यूमरेटरला आहे बरोबर आणि कुठली टर्म डिनोमिनेटर होती D त्यामुळे बरोबर डिनोमिनेटर आलेला कुठल्या व्हॅल्यू कॅन्सल होतील सांगा मला I from the numerator I from the denominator will get cancelled we have to put the value of Young's modulus 5 into 5.12 into 10 raised to minus 6 into 5000 raised to 4 divided by D into 384 into what is the E 1.2 into 10 raised to 4 and now D is equal to 5 into 5.12 into 10 raised to minus 6 into 5000 raised to 4 divided by 10 into 384 into 1.2 into 10 raised to minus 4. So depth of the section. Do the calculation properly and tell me the answer. Hmm? 10 raised to 10 raised to 10. 347.22. Okay. 3.47 into 10 raised to 10 कसं 347.22 correct. To do the calculation once again. Yes.
Young's modulus value 10 raised to minus 4.
347.22 mm. This is the depth of the section. Please check. Have got the answer? आले का तिकडे आन्सर? येते 347.22. Okay. So your calculation part is very important. Have what? No? How? Go. Young's modulus is equal to 10. That's why don't 10 raised to 4. It is not 10 raised to minus 2. So I have told, don't follow me 100%. So you have to tell me immediately what I have written, whether it is correct or wrong. Young's modulus is equal to 1.2 into 10 raised to 4. Purposefully, I am making the mistakes. How many of you are follow to me, or how many of you are not following, that I have to check. Don't follow 100%. Other 1.347.22 mm. Okay. Some of the procedure. If you read the statement, we cannot imagine how this bending stress equation is correlated with the slope and deflection formula. बरोबर. आता हे जर आपण प्रॉब्लेम जर आपण रीड केला तर ह्याच्यामध्ये बेंडिंग स्ट्रेस सिग्मा हे आपल्याला काय करायचं आपल्याला आपण त्याला तसा विचार करतो. बट हाऊ इट इज युजफुल फॉर द कॅल्क्युलेशन that we have to understand. Getting? So one problem will solve and then we will stop. So this will be the last problem on this chapter. So take it. Read the statement. A beam 3 meter long, simply supported at its ends, is carrying point load W at the center. Okay, again the type of beam is given simply supported. The length of beam is given 3 meter, and the point load is applied. Its magnitude is W. Okay, if slope at ends of the beam should not exceed 1 degree. So the slope value is given. It should not exceed 1 degree. Find the deflection at the center of beam. Find deflection at center of beam. Slope ची value दिलेले आहे 1 degree, and by using that we have to find out the deflection. W value is also not given. So first of all, you draw the figure. So this is the simply supported beam, that is point A, point B, point C. It is of W. The total length of the beam is given 3 meter. So this is the deflection in downward direction, YC. Theta A and theta B. So this is the figure. Other given values: length is equal to 3 meter, which is equal to 3000. W is not given. So theta A is equal to theta B, which is equal to 1 degree. So you have to convert in radian. So 1 into pi by 180. Degree to radian multiply by pi by 180. And radian to degree multiply by 180 by pi. 0.0, only 1 or 17 or 174. 174. Take all the digits, at least for this radian to degree or degree to radian. 0.0147 radian. And they have asked to find out YC. They have asked to find out the YC. So this is also again under the standard case, simply supported with point load. What is the formula? WL cube upon What is the theta formula? Theta A is equal to theta B. Now, see, we are having the formula. Directly, I can put the equation values. Length is given, E into I is given, W is given. No, then how to calculate? How to calculate? One trick is there. If you imagine, in the deflection formula, we have to apply the slope formula. Theta is given. Theta is given. बरोबर, जरी थीटा दिलेला असेल तर त्याच्यापासून आपल्याला जर W ची व्हॅल्यू काढायची म्हणलं तर E इंटू आय माहित नाही. बरोबर, E इंटू आय काढायचं म्हणलं तर W ची व्हॅल्यू माहित नाही. बट कॅन यू ऑब्झर्व the slope formula in the deflection formula? Can you observe? How the slope formula will get modified? How the slope formula will get modified? आपल्याला काय करायचं आहे? स्लोपचा फॉर्म्युला डिफ्लेक्शनच्या फॉर्म्युल्यामध्ये इमॅजिन करायचा आहे. L by correct. बघा, YC is equal to, हा फॉर्म्युला काय? WL cube upon 48 EI. हा फॉर्म्युला मी असा लिहू शकतो, WL square upon 16 EI into L by. Possible to write? काय करणार? WL cube हा फॉर्म्युला मध्ये काय केलं? WL square upon 60 EI आणि हा फॉर्म्युला जर मल्टिप्लिकेशन केलं WL square into L, WL cube E into I असं 16 into 3 48. हा फॉर्म्युला म्हणजे काय? YC is equal to theta A or theta B into L by. Then what I will do? YC is equal to theta A 0.0174 into 3000 divided by 3. YC is equal to 17.4. Yeah. समजलं? दोन अननोन पॅरामीटर दिलेलं नाही, बट we can divide the deflection formula in the form of slope formula. आणि आपल्याला लेंथ दिलेलं आहे त्यामुळे L by 3 आपण काढू शकतो आणि WL cube upon 16 EI म्हणजे तो कशाचा फॉर्म्युला आहे तुमचा? theta A and theta B. So directly I can put the theta A theta value which is given in radian and multiply by L by 3. You will get the deflection formula. Imagine होतो का फॉर्म्युला? WL cube upon 48 EI हा आपण कसा डिवाइड केला? एक म्हणजे WL square upon 16 EI आणि मल्टिप्लाय L by 3 आणि त्याचं प्रोडक्ट जर आपण सगळं कॉम्बिनेशन केलं तर परत तुम्हाला तो वरचाच फॉर्म्युला मिळतो. So this is the analytical method. Getting how to apply the analytical method? So we have to remind the list of the formulae and we have to apply them. So these are some sample problems based on the analytical method, that is slope and deflection calculation. And so with this we have finished the numerical parts of the slope and deflection. Okay, so only one point is remaining, that is the introduction part of the Macaulay method. So how the Macaulay method is useful for the slope and deflection, that we will understood in the next lecture. We'll take some introduction part, some important things which are required for the MCQ questions, and then we'll finish this chapter maybe in the next lecture. Okay.